Welcome to the DIY Honda Garage channel. This presentation focuses on the diagnostic trouble code DTC P2413, which indicates an EGR, exhaust gas recirculation, system malfunction. The EGR system plays a critical role in reducing nitrogen oxide, NOx, emissions by recirculating a portion of the exhaust gases back into the engine's intake. This process not only helps in lowering harmful emissions, but also aids in improving the overall efficiency of the engine. In the 2011 to 2015 Honda Civic, key components involved in the EGR system include the EGR valve, the EGR valve position sensor, and the engine control module, powertrain control module, ECM/PCM. The EGR valve is typically located on the intake manifold, while the ECM/PCM is usually situated near the engine bay. When the DTC P2413 is triggered, it indicates that there is an issue within this system, which requires immediate attention for resolution to ensure compliance with emissions regulations and optimal vehicle performance. The EGR system is vital for managing and reducing the emissions generated by the engine, specifically nitrogen oxides, or NOx, which are harmful pollutants. The EGR valve allows a controlled amount of exhaust gas to mix with the incoming air-fuel mixture, which lowers the combustion temperature and subsequently reduces NOx emissions. In this system, the EGR valve position sensor is responsible for monitoring the position of the EGR valve, ensuring that it opens and closes at the correct times as dictated by the engine management system. This sensor sends feedback to the ECM/PCM, located in the engine bay, enabling it to make precise adjustments to the engine operation. If any part of this system fails, as indicated by DTC P2413, it can lead to increased emissions, poor engine performance, and potential engine damage if left unaddressed. The DTC P2413 can arise from several potential issues within the EGR system. Firstly, a failure of the EGR valve itself can prevent it from opening or closing correctly, leading to irregular exhaust recirculation. If the EGR valve position sensor is faulty, it may give incorrect readings to the ECM/PCM, indicating that the valve is functioning when it is not. Additionally, wiring problems, such as short circuits or open circuits in the wiring harness that connect to the EGR valve or the ECM/PCM, could disrupt the normal signals and operations of the system. It's critical to investigate each of these potential causes thoroughly to ensure that the root cause of the error is accurately identified and resolved to restore proper EGR functionality. When DTC P2413 is triggered, it can manifest through various symptoms that affect vehicle performance. One of the most notable signs is an increase in harmful emissions, which can result in failed emissions tests and impact environmental compliance. Drivers may experience a decline in engine performance, characterized by a loss of power or reduced acceleration, as the engine struggles to operate efficiently without the EGR system's assistance. Rough idling is another common symptom, as improper recirculation of exhaust gases can disturb the air-fuel mixture, leading to unstable engine behavior while idling. Observing these symptoms should prompt immediate diagnostic efforts to assess and rectify the underlying issues represented by the DTC. The first step in troubleshooting DTC P2413 is to verify the problem with specific ignition procedures. Begin by turning the ignition switch to the on position, which powers up the vehicle's electrical systems. Next, clear the DTC using the HDS, or Honda Diagnostic System, which resets the onboard diagnostic memory. After clearing the DTC, start the engine and hold the engine speed at 3,000 RPM without any load. This means the automatic transmission must be in P or N and the manual transmission in neutral. Maintaining this engine speed until the radiator fan activates is critical in ensuring that the engine reaches operational temperature, allowing the system to be tested effectively. Following these steps will prepare the EGR test in the next phase of troubleshooting. In Step 2 of troubleshooting, the primary goal is to identify any failures based on the EGR valve position sensor readings. Start by turning the ignition switch to the lock position, which completely powers down the vehicle's electrical systems. Then, switch the ignition back to the on position, energizing the circuits again. Utilizing the HDS, check the EGR valve position sensor readings available in the data list. Specifically, assess whether the EGR valve position sensor, VLS, indicates a voltage close to 0 volts. This low voltage reading would indicate a potential fault with the sensor or the wiring affecting it. If the result shows about 0 volts, you will proceed to the next step. Otherwise, further troubleshooting of the system is warranted. In the third step of troubleshooting the DTC P2413, focus shifts towards checking the VCC2 line, which supplies voltage to the EGR valve. Start by turning off the ignition by switching to the lock position. Next, disconnect the EGR 5P connector to isolate the EGR valve from the circuit. With the ignition in the on position, you will measure the voltage at specific test points to determine whether approximately 5.0 volts is present. This testing condition is vital as it helps diagnose the integrity of the VCC2 circuit that energizes the EGR valve. Proper voltage indicates that the circuit is functioning as expected. If voltage is present, you can proceed to the next step, but if absent, it indicates an issue that needs further investigation. Step 4 involves examining the VCC2 line for open circuits. Again, begin this process by turning the ignition switch to the lock position to power off all systems. Next, utilize the HDS to jump the Stimulus Communication System (SCS) line, which facilitates diagnostic communication with the vehicle's electronic systems. With the SCS jumped, disconnect the ECM-PCM connector B, which comprises the connection to the engine's control module. The objective now is to check continuity between the specific test points to determine if there is an open circuit within the VCC2 line. If continuity exists, you can conclude that the VCC2 wire is intact. However, if no continuity is detected, this suggests a break in the wiring that will need to be repaired. The fifth step focuses on verifying the EGR-L line for any short circuits. As before, turn the ignition to the lock position to shut down the electrical systems. Following this, jump the SCS line with the HDS for proper diagnostic communication. After this setup, disconnect the ECM/PCM connector B again to isolate the module from the diagnostic process. At this point, you will measure continuity between the test points for the EGR-L wiring. If continuity is present, you can conclude that the EGR-L wire is intact and without shorts, allowing you to proceed to the next tests. In contrast, if continuity is detected, you need to investigate repairs for any short within the EGR-L wire. Step 6 continues the investigation into the EGR-L line, focusing on potential open circuits that may be hindering system operation. Utilize the same initial conditions as prior steps, ensuring the ignition is set to lock and the relevant connectors are disconnected. Now, check the continuity between the test points specified for the EGR-L line. A successful continuity test indicates that this particular wire is functioning correctly, supporting the operation of the EGR valve. However, should you find no continuity, there is an open circuit condition that needs to be addressed. You'll need to locate and repair this open wire connection between the ECM, PCM, and the EGR valve. In the 7th step, the focus is on the internal circuit of the EGR valve position sensor. Start by ensuring the ignition is in the lock position before disconnecting the EGR 5P connector to isolate the sensor. It is at this point that you will measure the resistance between 2 points at the EGR valve side. A resistance of 100 kiloohms or more is necessary to confirm that the internal circuitry of the position sensor is functioning correctly. If this resistance value is met, it suggests that the EGR valve position sensor is operational, and you can then proceed with further repair verification. Conversely, if the measured resistance is below this threshold, then you will need to replace the EGR valve to resolve this issue. Step 8 builds upon the previous checks to further evaluate the EGR valve position sensor. With the EGR 5P connector still disconnected and the ignition set to lock, it's necessary to measure the resistance across different test points on the EGR valve. If the resistance is found to be 100 kiloohms or more, it indicates that the internal circuit of the position sensor is functioning well, suggesting that the EGR system may be in good health. However, if the resistance falls short of that value, further intervention is warranted. At this point, replacing the EGR valve would be necessary to address potential faults in the sensor that could lead to persistent errors or emissions problems. As part of troubleshooting DTC P2413, the 9th step examines the EGR line for any potential short circuits. Begin by ensuring that if the ECM-PCM connector B is connected, jump the SCS line with the HDS to maintain communication with the vehicle's diagnostics. Then, disconnect the relevant connector to isolate the EGR line further. Measure continuity between specified test points to determine if there is a short condition present in this circuit. If continuity is found, it indicates that the EGR wire is potentially compromised and may need repairs. If there is no continuity, you will move on to step 10 to continue diagnostics on this line. In the 10th troubleshooting step, the aim is to assess the EGR line for any open circuits. Continuing with the ignition at lock and both the EGR 5P connector and ECM-PCM connector B disconnected, measure continuity between the specified test points. If continuity is verified, it means that the EGR line is functioning correctly and allows for signal transmission back to the ECM-PCM. If continuity fails, it indicates that there is an open circuit requiring immediate attention. At this point, you will need to locate and implement necessary repairs for any identified open conditions in the EGR line. Step 11 focuses on checking the PG line for continuity, which is essential for the EGR valve function. Start with the ignition set to lock and confirm that the EGR 5P and ECM-PCM connectors remain disconnected from the circuitry. Measure continuity between the specified test points for the PG line. If continuity is present, this indicates that the PG wire is intact and has no faults. In contrast, if continuity is lacking, it suggests that there is an open circuit present along this line. This requires addressing and repairing the open fault in the PG wire to ensure communication and function of the EGR valve. In the 12th troubleshooting step, you will assess the operational integrity of the EGR valve itself. Begin by reconnecting the ECM/PCM connector B to restore the connection to the engine's control module. At this point, you will take a jumper wire and connect terminal A from the EGR valve 6P connector to the battery's positive terminal, effectively providing power directly to the valve. After initiating this connection, start the engine and allow it to idle. Subsequently, perform the opposite connection by jumping terminal A to the battery's negative terminal. The resulting engine behavior will indicate whether the EGR valve is functioning properly. If the engine stalls or runs roughly, it signifies that the EGR valve is operational. If no change occurs, further diagnostics into the EGR system is warranted. The final troubleshooting step involves a thorough cleaning of the EGR system components to ensure they are free from obstructions that could hinder performance. This entails turning the ignition off and removing the EGR valve from its mounting position. Use a throttle plate cleaner to clean both the intake manifold EGR port and the passages inside the EGR valve itself. Once cleaned, reinstall the EGR valve securely, ensuring all connectors and fittings are properly reattached. After completing the physical cleaning, turn the ignition to the on position and reset the ECM/PCM with the HDS. This will prepare the system for a fresh diagnostic evaluation. Lastly, perform an EGR test with the HDS to verify functionality. If the system tests satisfactorily, it confirms the EGR components are operating correctly. A final repair verification step is crucial for confirming that all previous diagnostic and repair actions have resolved the DTC P2413 issue. Start by turning the ignition to the lock position and ensuring all corresponding connectors are securely reconnected. Switch the ignition back to the on position and reset the ECM/PCM using the HDS. Following this reset, perform the idle learn procedure to allow the engine management system to recalibrate itself to the engine's characteristics. Run the EGR test once more with the HDS and meticulously check for any pending or confirmed DTCs. If DTC P2413 is indicated again, it will be necessary to revisit all previous connections and logic to ascertain whether any loose terminals or poor connections still exist. If no issues are present, your troubleshooting is complete and the vehicle is ready for use. Preventive maintenance is essential to ensure the longevity and efficiency of the EGR system and to avoid future issues related to DTC P2413. Implement regular checks of the EGR system, making sure to monitor for any signs of wear or malfunction in components such as the EGR valve and position sensor. Keeping the EGR system and associated passages clean will minimize blockage and improve gas flow. Regularly updating the ECM/PCM software is also crucial, ensuring that the most up-to-date revisions from the manufacturer are applied. This can prevent potential miscommunication issues between components, ultimately leading to a smoother, more efficient engine operation and reduced emissions. In conclusion, understanding DTC P2413 and its implications on the EGR system is critical for effective vehicle maintenance. The EGR system plays a vital role in controlling harmful emissions, and when malfunctioning, it can lead to serious performance issues. The troubleshooting steps outlined provide a thorough approach to diagnosing the problem, ranging from initial checks of the system to detailed inspections of wiring and components. It's essential to follow these steps carefully to ensure a proper resolution. Regular preventive maintenance can mitigate issues related to the EGR system and ensure your Honda Civic continues to operate within emissions regulations efficiently. Remember, timely diagnosis and repairs not only enhance vehicle performance, but also contribute to a healthier environment. Please like and subscribe to the channel. See you next time.